when you are processing this data, you can reduce the delay, as well as also you can increase the speed of our processing. So that's why we are choosing whenever we are, as per this title itself, we are having that edge computing and will add value and speed. So as per the speed, we are reducing the delay and increasing speed of your processor. That's why we are choosing, specifically choosing this. And also we have improving this reliability. In what way we can improve this reliability in the sense? So reliability, normally this reliability also can be improvised with this help of this edge computing, and also we can increase this security. So security, I told you that security is one of the important aspect, whatever the key component you are embedding with this application. Even whatever the process execution you have carried out, you should provide high security. So then when you are applying this edge computing, you can provide a high security to enhance the securities also, and enhancements will be available in this edge computing. And cost, so I told you that we have this cost is one of the important concern when you are working on this high performance computing. If you are embedding this edge computing along with your HPC, so in future may not be, so a lot of people, their industry people, they are working already. But even though people are working on industry, that in future, so each and everything so just keep on changing, the versions also changing. But we have an standard thing, so to be enhancing this reducing this cost of edge computing to be applied in your AI. And it supports as per this 5G enabled latency. SLA is one of the drawback in your centralized data center. When you're applying this high performance computer, this in what way we can call it as this is more powerful and valuable. So in what way I can call it as this is more powerful in the sense when we are applying this IoT. So normally this edge computing will support IoT, and even we can add more number of emerging technologies also we can add along with this edge computing. But it's a well known domain which is applicable to integrate this edge computing to increase the speed, is we can apply this IoT concepts. You can apply IoT to get a better speed of your work to apply this high performance computing. I think everyone can understand whatever I'm trying to explain about this particular topic. And while moving on to the next slide, so this particular concept is HPC will become even more accessible as a service in your cloud. When you are discussing about this high performance computing, we have some services also. We have normally in your cloud computing, you'll be having three services: SaaS, PaaS, this infrastructure as a service, this platform as a service. So some categories of service will be there. But when we are integrating this high performance computing, this particular uh, key component is, we have some different advancement in this HPC cloud services. When you are working on this HPC CAAS, it's as a service revolution. Why? Because when you are having this high performance computing, if you are applying this work in high performance computing, we have deploying things will be there. Why? Because the services will have cloud. It's also a kind of cloud network. But in cloud normally we have three different services. So this HPC will have a different service. This service will have a better service will be having to vendor. It may be switching from selling or any other HPC related equipments. This HPC have provided specifically for this AWS and this Google, Alibaba, and HP. The others are already working on this HP has the HPC. Normally this is just a service where we can where who are all working on this high performance yoga high performance also will be there. Then when discussing about this cloud services, high performance computing as a service, it is it's one of the powered largest computing will be applicable for all some of the largest companies already they are working on it. That's why we are specifically choosing this HP cases as a service, and also we are integrating this HP services along with different computers as well as storage, softwares, and services. And we have a different work to completing a successful project. You can apply this HP services as a special service. To there is no virtualization. Normally if you are applying this cloud concept, you'll be having this virtualization. But when you're applying this HPC, no HPC as a service, you'll not be having any virtualization. You'll be having huge data storage capacity. And if you are applying this, and you'll be getting a better storage. Why? Because our high performance computing is mainly focusing about this storage creating multiple storage on this debate. So if you are applying this HP as a service, HP, high performance computing as a service, that will be having in a high bandwidth range will be available. You can apply high bandwidth, as well as it will be having a low latency network, and also it will be having a complete job scheduling technique will be there. Why? Because if you are allocating multiple works at a time, so based on the priority based, this work has been allocated. When applying this job scheduling, this whatever the allocated work you are having, that will be scheduled in a queue and managed throughout whatever the cycles you are carry out in this. And also we have different life performance file system also will be there. So why we have to use this performance file system in this HP case, in the sense, if you are applying this service, what SSD solution also will be available to provide monitoring all this system properties, as well as if it is any black hole mitigations techniques also. A lot of mitigations are there. White or hole mitigation, you can also include this black hole mitigation to monitor the systems. What are the process which is happening inside this process. You can able to easily monitor this black hole mitigation technique. And also maintenance also is very important. When you're applying this services in in your processor, this HPKs, monitoring and maintenance is very important, as well as you can apply this to get a better performance in feature, as well as nowadays so many companies or industry people, they are working on this mainly for the security reason. The HPK service is mainly for us services. And also authentication is also more high, and all the things will be having better things. But we can go with, we can apply all the processors, whatever the processor you want, GPU or KNL or 10 GB high speed Ethernet fabric. Also Ethernet also you can apply for this particular services. But when you are applying any software algorithm, developing any algorithm for a specific application, you can go with the special technique that HP services. The main thing which is related to this HP services, services will be providing a high service as well as a security reason. We are applying this HP TV and accessibility, a service oriented architecture. So this particular concept is also a kind of feature trends will be related to your high performance computing. I think you can understand what I'm trying to explain in this particular concept. And while moving to the next one, GPU computing, and when we are discussing about this GPU computing, so GPU, everyone knows that without GPU, GPU, we are working a GPU along with your HPC. GPU computing is one of the important source nowadays. Why? Because everyone, those who are doing research or anything, else, everyone required this GPU. And what are the advancement will be available in your GPU servers, in the sense? I'll move to the next slide so that you can understand what is the title behind this fourth features and trends. And everyone knows, that's why this GPU is one of the important part of our research work nowadays. Without GPU, we can't able to compute larger number of data sets to improvise our result. So improvising our research, your GPU server will provide lot of gen nowadays, lot of gen AI intelligent automation also will be available. But when you are exploring something related to this GPU, we have, a lot of versions will be available. 8 GPU server, dual maybe will dual 10 GPU server, dual Intel. So different industry people, they are, Pro also will be there. Pro 8 GPU server, dual AMD Pro will be available, and even 10 eGPS also will be there. So many versions will be there, but applicability and suitability of our work, based on that we can apply whatever the GPU requirement will be suitable for your work. So even why, because we are choosing this GPU computing, normally when we are working on any particular concept, you can go with this GPU computing. But this GPU computing, have cost wise it may be somewhat high, but we can get a better results, as well as better computing technology will be suitable for your HPC. That's why this GPU will be suitable. That's why I told you that we have for a few more lot of different versions and services, solutions also will be there. Services in the sense, we have, even though if we are having whatever the GPU services we are having, we can go with even different companies, they are going with different CPUs. The main advantages is when we are working on this GPU is, in what way we can cluster the GPU with our HPC, in the sense. So we can cluster both the CPU and GPU. Why? Because when you're clustering or combining the CPU as well as GPU in your HPC, we can perform a different operation. Why? Because GPU is only for this power resource intensive computing operation, but CPU will perform in a serial processing. But now, as per this HPC concern, we are handling this parallel processing concept. But when you are performing a different operation, you can cluster with CPU as well as GPU, to perform a better actions and operations. And also, I told you that GPU are used to power resource intensive computing. So it is specifically used for this the power intensive computing, and as well as this operations behind this is, GPU will handle all the power resource intensive computing operations, but CPU also we are integrating along with this. When we are integrating the CPU, it will perform as only serial processing. But even though when we can apply some sort of application to handle these GPUs, and what are the merits and major merits of this GPU applying in your HPC, in the sense? So if you are applying this GPU computing, it may be, a lot of researchers, they are having a larger amount of data sets. But even I know, we know that larger data sets will be, executed with help of GPU alone, not a CPU, based on this time constraint, as well as this data faster, in a faster way the data can be handled, as well as this, efficient way, cost wise, a lower cost than using only CPUs. When you are applying this GPU, a GPU will have, the cost wise it is more, but when you are using the CPU, it is somewhat low. But advantage of applying this GPU is, when you are applying this large amount of data transfer, as well as, execution, the way we are applying this, data in your GPU will be more efficient, as well as, you can get a better research as well as a faster way. That is the main advantage we are applying this GPU in your high performance computing. And the applications where we can apply this GPU, in the sense, some, even though when we are applying this GPU, we have some challenges. What are the challenges? Even if the developer, or I know that when we are doing this developing part, debugging multiple GPUs at a time, it will be very difficult. Why? Because multiple we are giving multiple processing at a time, in the sense, it will take some debugging issues to get a, applying in this GPU in your real time aspects. And also we can go with, planning accordingly, as well as, hypervisor. You can apply VM storage and network resources to configure, better practices for managing this HPC in your GPU. So if you are applying, in what way you can, apply this GPU as a specialized process unit in your HPC, in the sense, we can apply maybe in any sort of application. Why? Because AI itself we have lot of application gaming. So as per the slide itself, we have given some list of applications that is specifically designed for gaming, or GPU, gaming or AI application, different AI application, as well as mathematical computation to improvise the enhancement of your mathematical computation in different aspects. You can apply this GPU as a key and one of the best example for your HPC. And also we can choose, this NVDA, normally we can call it as NVDA GPU. The recent versions and the working trends, the industry people, they are working on this GPU workload as NVDA A100 version is there, B100 is there, Tesla T4 is there. So many versions are there. You can choose any version with this and you can work on it to execute in an efficient way. And as per this application concern have given is, HPC include weather forecasting, data mining, and other processor. It may be specifically for the speed and amount of data computation. That's why we are using this, GPU. And largest maker of GPUs in NVIDIA, NVIDIA is, core developer. They are having this GPU. That's why the name which is given by this GPU is NVIDIA and NVIDIA GPU. For gaming purpose, gaming or any other applications, they are giving this NVIDIA A100 version, NVIDIA V100 GPU, Telsa T4 version. You can choose whatever the version you want, suitability of your work, as well as RTX AI 6000 also will be there, NVIDIA RTX 4090. So many versions are there. But this is only, having a better results and producing in a better application suitable for your deep learning application. That's why, even whatever the machine learning, even whenever discussing about this AI, we have this approaches call it as namely this deep learning approach and machine learning approach. This particular NVIDIA RTX 6000 will be suitable for any deep learning approaches. It may be an NVIDIA A100 or NVIDIA 6000 also will be there, RTX 6000. But you can choose whatever the relevancy which is will be required for you. You can go with that. And when we are discussing about this HPC storage, so GP, normally we'll be having more data storage, to do the graphical aspects. That's why this gaming and graphical applications also will be suitable for this. And apart from this, we have, form of a matrix, maybe some sort of a mathematical applications also will be applicable to apply on this particular GPU computing. So this is also a kind of, and I think you can understand whatever the key concept which is having in your GPU computation. So this GPU computation will be on the rise. Rise is nothing but you can add whatever the version you want to, club along with your GPU in different applications to get a better results on your HPC. And while moving on to the next one, this modern data storage will be critical investment. That's why, obviously, whoever working on this particular domain, they can understand, why, because what all the problems they are facing on this particular issue. Why? Because even if we are having this execution part, storage is one of the key concept, that modern storage will be critical investment. Why? Because when you are computing something else, whatever the process it may be, we have three components, three major key components, that is computing, networking, and storage. Why? Because previously when we are discussing about this key components of your HPC, we have listed, have listed four key components. But even though we have three key components which is related, related to your high performance computing, that is computing feasibility, networking, and storage. Why we are, focusing at the key component, the three main key component in the sense, but computing efficiency of your computing is very important. Even though whatever the things it may be, the efficiency should be very, very important, very keen, whatever the application we are working on it. And this HPC system, data storage, and the networking part. That's why networking we have a cloud. We can use IoT as well as the storage part, we can go with the cloud as a service. That's why we have discussed about this HPC AAS, high performance computing as a service. So whenever we are discussing about this computing, networking, storage, so you can choose which is relevant to that. Why? Because storage is normally one of the important aspect to work on this HPC. So whenever you are moving on to this store networking part, you can go with this IoT and other applications. Storage, you can choose uh, for this feature enhancement. For feature application, you are applying in HPC. So storage, you can go with this HPC as a service, HPC as a service. And after discussing this elements, key elements, what are the things can be able to do with this HPC? So if you are making a data, it'll handle any size of data request. Why? Because any size of data is based on this HPC high performance computing. The capacity of this data storage, it's varies from different things. Why? Because this capacity which is already handled, but even this capacity, storage capacity, if you are handling more than 1 lakh data, 2 lakh data, or 3 of whatever the data set you are having, it will handle any size of data request to execute your results. And it supports performance oriented protocols. Why? Because we are having the key component as network. Even though whatever the performance you are having, it always support all the performance oriented protocols to execute in a better way, as well as this scale rapidly to keep up with increasingly demand latency SLAs. The service layer architecture, different service layer architectures are there for to improve, increasing this latency of this HPC. We can apply all this service level architecture, and also you can use if you want to increase this the data storage, you can keep on increasing this feature trends to apply all these 5 key applications in your domain, and you can work on this particular aspect. You can get a better results to improvise your performance. I think you can understand now. So we have listed 5 key components to be increasing the features of your high performance computing. As per this, first one is AI. I think you can understand this AI. And second one is edge computing have discussed much more about this edge computing and roles and feasibilities. What are the advantages behind this edge computing to apply in this high performance computing, and this HPC more accessible to the services. So services, I told you that storage, for a specific storage aspect, you can go with this HPC as a service. And fourth one is GPU computing feasibility to rise the increasing aspect. You can rise this computational speed as well as data computation process. So this is your fourth one, and the last one is the modern data storage. Will be a critical investment. Anyway, even if it is a critical investment, we'll get a better results, as well as we have an improved accuracy. So a lot of advantages are there, but only thing is investment of your data storage is somewhat high when you're applying this high performance computing. So investment is, even if it is a lakh, it is okay, but even it is moving on to this core or whatever the ranges, it starts from more than that. It is very difficult to afford all those things. That's why we are applying this. One of the demerits which is applicable in your high performance computing. But even though if we are getting good results, we can move with that based on the requirement. And as per this graph, this graph, it shows that how long this, Tesla and other versions which is applied at this high performance computing with the different values and ranges will be there in your slot. So it starts from this versions of chips, number of chips which is integrated in this version. It starts from, this NVIDIA, it starts from 12 trillion. Now we are having 886 trillions of chips we are having, up to, the forthcoming years will be having, 2025. Now we know anyway this year is going to be end, even 2025. 2025, we are having this 536 trillions after, in future, for even if it is up to 231, the expected chips and working efficiency of this high performance computing will be increasing. This is the kind of survey which is available in our IBM website. So they are giving a tentative survey to be applicable for your high performance computing. In what way this hardware and what kind of chips they are embedding with all this application. So as per this application concern, we are starting, I told you, when we are starting this origin, it starts from 12 trillion. Now, when we are in 2025, so 2023, it is 420 trillion. So within this 2 years duration, it's 2025, normally this trillions will be increased to more than, 100 or so. Now we are, when we are entering into this 2025, we'll get 536 trillions of chips, 2025. So you can, even though you can increase more efficiency when you are applying this high performance computing. So as per this chart, you can understand the ranges in the horizon it starts and the way it's moving on. Every year we are increasing this number of chips to increase the processing speed as well as storage, and different aspects we are applying this particular what way it will be useful, and also in what way this will be helpful to your real-time application. So now as per this picture you can understand too. Then as per this application we have discussed feature trends. Even when you're discussing about this feature trends already we have discussed no five key feature trends, and also some application related to that feature trends which is given over here. So as per this application where we can apply this and what are the application we have discussed, even though we can give some a clarity over on a specific domains where we can apply this. And this first concern is space science. So if you can apply this astrophysics or astronomy wherever you have this computations, we are collecting larger data sets from the space, you can apply this astro HPC. You can get a better clarity on it, as well as earth science. If it is geological structure, water resources modeling, seismic exploration, whoever working on the particular this particular applications, you can go with this HPC. Whatever the application may be relevant to this earth science, you can use this HPC to get a better things. And the third application is atmospheric science. It may be any climate change or whatever it may be, you can go with this that you will get a better results on this while applying this particular concept. Then the other application which is given here over here is space science. So some few examples which is related to that work I have listed over here. So you can, as per this discussion in your previous slide, space science, earth science, atmospheric science, for collecting some high quality weather forecasting, climate changing. So everything will be applicable. You know why? Because wherever the application which is served over here, in all domain, we have larger data sets to be applicable in this application. That's why we are using this application for your specific high performance. Then IBM. So this, when you are looking on this glimpses of this IBM, specifically those who are working on this NVDA and as well as the IBM, they are, they are developing this high performance computing. They are providing some solution to work on this particular application. That's why you have listed of some of the industries who are working on this high performance computing to produce a better results. And the first thing you have listed is IBM. Why? Because they are, handling larger data sets as well as, hybrid approach also they are applying to increase the speed as well as, to providing a better solution with the help of this IPC. That's why I have listed this IBM, they are providing this high performance computing solution for this particular HPC. And well, moving on to this Discover HPC and IBM Cloud and also its tools, this IBM Spectrum tools and all the different portfolios. It may be virtualization or it may be any workload management providing this integrated HPC environment. It may be any critical application. You can go with this IBM Spectrum. So this is also a kind of portfolio will be applied on your high performance computing to get a better results. And along with this, we have the two more concepts which is available, related to this IBM services. So when you are applying this IBM service, you can choose this IBM Spectrum. That is one of the suitable application you can apply on this whatever the work you want in this particular. And as per this IBM, we have a virtual server also we have. As per this virtual server concern, virtual normally if we are going for the storage or purpose, we can go with this virtual server. Why? Because this configuration will be, highly comfortable with this IBM cloud. This is only for specifically for storage services. Why? Because when we are having larger data set, we are not supposed to store in our system or whatever the server we have, that the capability and capacity of the server will not be sufficient to store all the information, so that we are moving to this IBM power and virtual server. You can use this virtual server to work on it and for the storing purpose. And as well as we can explore this IBM virtual server along with this Spectrum Symphony. This is also a software they are delivering for open source platforms, and you can work with this open source platform as well as you can gain knowledge on this particular concept that will be useful for you to whoever working on this high performance computing. So this high performance computing is one of the recent domain we are working on it. You can apply whoever working on this domain, and you can get a better results, and also you can get a better result in the form of your research or any other application you are working on this high performance computing with help of this any softwares or any tools which is available in the market. I think you will get.
Hello, ma'am. Hi, all. I think she
It's,
got dropped. Huh?
no, I've completed. And is there any queries we can go with that?
Yeah. Yes. Thank you, ma'am. Thanks a lot. Any
Thank you
doubts or any queries?
for the
We
opportunity.
do.
Thank you for the
Thank you, ma'am.
opportunity by you. Such a wonderful session as well.
Thanks a lot, ma'am. Thanks for sharing your insights, and it was really useful. And I hope this session would be helpful for them to gear up for on the final concept as part of this Atal FDP. Thanks a lot for sparing your time, ma'am.
Okay, sir. Thank you, sir.
Thank
Any
you, ma'am.
questions?
Any queries or any questions you have, participants? Okay, I think they are not having any questions.
Okay,
So,
sir.
thank you, ma'am. Thank you. Thanks a lot for the session. Thank
Okay,
you.
thank you. Thanks for
And
your patience. Thank you, everyone.
thank you, ma'am. Thank you. And dear participants, as you are well aware, now the quiz, which is part of your the 6J FTP, you'll be having it. And do let me know whether you are able to log in and take the quiz.
So, shall I?
Yeah, yes, ma'am. You can drop off, ma'am.
Okay, thank you. Thank you, sir.
Thank you, ma'am. Thanks a lot. Dear participants, please wait for another 5 more minutes. I will share the link. Okay. If you are able to take the test online, it will be fine. Otherwise, also I will share the link. Kindly do wait.
ஏய், இங்க வா, இது என்ன ஒரு டெஸ்ட்டுக்கு எப்படி போறது?
உள்ள லாகின் பண்ண முடியுதா? Are you able to log in?
John on the team. Kanishka, வாங்க. அப்படியே வச்சுக்கோ chat GPT. Chat GPT என்கிட்ட இல்ல. அதுல போய் சர்ச் பண்ணு கனிஷ்கா.
மேம் ஜெயந்தி மேம்,
Yes sir.
மேம் நீங்க மியூட் பண்ணிக்கலாம். You are unmuted. We can hear you. ஹலோ, அதே நம்மளுடைய அட்டல் எப்படி ஒன் செகண்ட்.
So we'll start.
Yeah, yes, ma'am.
The end of a session is not the end of learning, but the beginning of application. With this thought, we will now move on to the valedictory session of the 6 days faculty development program on high performance computing. I request Dr. K. Venkatraman, Department of CSBS, to deliver the welcome address.
Yeah, thank you, ma'am. Uh, Thank you. Uh, Dear participants, esteemed guests, respected family, faculty members. It is with profound sense of accomplishment that I welcome you all to the validity function of a AICT sponsored online 6J faculty development program on high performance computing, transforming research through advanced technology. On behalf of our esteemed institution and the organizing committee, I extend a heartfelt welcome to all of you who have contributed to the success of this enriching program. Over the last 6 days, we have delved into the intricate world of high performance computing and explored its pivot role in accelerating research and innovation. The insights shared by our distinguished speakers and the active engagement of our participants have made this FDP a fertile ground for intellectual growth and technological advancement. As we gather virtually to celebrate the conclusion of this program, I wish to express my deepest gratitude to All India Council of Technical Education for their support, to our expert speakers for their invaluable contributions, and to you, our participants, for your eagerness to learn and apply these advanced technologies in your research endeavors. Let's carry forward the knowledge and skills acquired during this program to transform research and create a significant impact in our respective fields. I once again welcome you all to this validatory function, and I look forward to commemorating our collective achievements. Thank you, ma'am.
I now request our principal, Dr. Venugopalakrishnan, to deliver the valedictory address.
Good evening to one and all. The respected dignitaries and the esteemed faculty members, distinguished resource persons, the participants, and my dear colleagues. It is indeed a moment of great pride and satisfaction for me to address you all on the valedictory function of this highly successful 6 days faculty development program organized under the visionary initiative of the AICTE Training and Learning, that is the Atal Academy. Over the past 6 days, we have come together in the spirit of learning and collaboration to delve into the transformation themes of high performance computing. At the outset, I would like to extend my heartfelt gratitude to the organizers and the coordinators who made this event possible. The ACT Atal Academy has been a beacon of excellence in advancing the knowledge and skills among faculty across the nation. Their commitment to the professional development of educators is exemplary, and it is through such initiatives that we can collectively strive towards academic excellence. This FDP has a journey of intellectual exploration, collaboration, and innovation through insightful sessions of visualization of high performance computing, security of HPC, and its insights. We have had the privilege of engaging with some of the finest minds in the field. These sessions have not only deepened our understanding, but have also equipped us with the practical tools and methodologies that can be implemented in our classrooms and research endeavors. The active participation and enthusiasm displayed by all attendees throughout the program have been truly inspiring. Your dedication to the enhancing your knowledge and skills is a testament to the commitment educators must have in shaping the futures. Each one of you, by embracing lifelong learning, is contributing to the larger mission of building a robust and progressive education system. It is said that education is the passport of the future, for tomorrow belongs to those who are prepared for it today. This program has indeed prepared us for the future by fostering a spirit of inquiry, innovation, and adaptability. As educators, it is our responsibility to not only impart knowledge but to inspire creativity and critical thinking in our students. The learnings from this FDP will undoubtedly help us in achieving this goal. I take this opportunity to express my sincere thanks to the resource person whose expertise and dedication have been pivotal in the success of this FDP. Your willingness to share your valuable insights and experience has enriched our understanding and has left a lasting impact on all participants. I also wish to acknowledge and appreciate the efforts of the organizing committee and especially the coordinator, Dr. K. Venkatraman, the Associate Professor, Department of CSBS, and the coordinator, Dr. S. Bhaskaran, Associate Professor ECE, and also COE. Your meticulous planning and seamless execution have ensured that every aspect of this program runs smoothly. From coordinating with speakers to managing logistics, your hard work has been commendable and we are grateful for your contribution. As we conclude this program, I would like to emphasize the importance of applying the knowledge and skills gained here. Learning is most impactful when it is translated into action. Let us all make a conscious effort to implement the innovative strategies and ideas discussed during this FDP in our teaching, research, and administrative practices. Furthermore, let us not view the valedictory function as the end of our journey, but as the beginning of new collaborations and opportunities for growth. The networks we have built here are invaluable, and I encourage all of you to stay connected and continue exchanging the ideas and best practices. Before I conclude, I would like to leave you with the thought: education is not the filling of a pail, but the lighting of a fire. Let us all strive to ignite the flames of curiosity, passion, and excellence in our students' lives and ourselves. Together, we can create an environment where learning is a continuous and joyful process. In closing, I once again extend my deepest gratitude to all those who have made this FDP a grand success. I congratulate all participants for their active engagement and commitment. May the knowledge you have gained here serve as a guiding light in your professional journeys. Thank you and wish you all a very best in your future endeavors. Let us continue to inspire, innovative, and impact lives positively. Thank you.
Thank you, sir, for your very insightful observations. I now request Dr. S. Bhaskaran, the Controller of Examination and the coordinator of this faculty development program, to propose the vote of thanks.
Thank you, ma'am. Good evening to one and all present here. It is my immense pleasure to deliver this vote of thanks in this 6 days faculty development program. As we bring to close this enriching faculty development program, I am filled with a profound sense of gratitude and behalf of JPR Institute of Technology and the organizing committee, I am honored to extend our collective thanks to all those who contributed to the success of this AICT-sponsored faculty development program. First, I would like to thank our Managing Director, Dr. N. Maria Wilson, sir, for his support and guidance. And I would like to thank our Principal, sir, to support for this successful conducting 6 days faculty development program. And I express our deepest appreciation to the All India Council for Technical Education for the sponsorship and support. The dedication to the enhancement of technical education in the foundation upon which this program was built. And I would like to express my sincere thanks to our distinguished speakers for their invaluable contribution and for sharing their expertise in high performance computing. Their engaging presentation and interactive sessions have greatly expanded our knowledge and will undoubtedly influence our future research endeavors. And I would like to express our sincere thanks to enthusiastic participants and our faculty members for in this 6 days faculty development program. And once again, I express my sincere thanks to all the participants in this for the successful completion of this 6 days faculty development program. Once again, I thank you all.
Thank you, sir. We will now end this session. Thank you.
Ma'am, just a minute. Any participants, would you like to give the feedback? Could you please turn on the video and give your feedback about the 6 days Atal FDP? Any participants, please? Can you just turn on your video and give your feedback, please? So, Balasubramanian, sir.
Hi.
Good evening to you. This is Dr.
Yeah, yes, sir.
Of Artificial API Institute of Technology. This is an opportunity for me to give a feedback about the 6 days FDP program.
Sir, can you bring the camera closer to your face, sir? Can you bring your camera down? A bit down, sir.
Is it?
Yes, sir. Yes, sir. Please, sir.
The key highlight of this program is most of the resource persons were very good, expertise in chosen area. Especially the first day of the Pakistan Technology Trichy have given basics of computing, covering single core architecture, multi-core architecture, parallelism, application, and their constraints. Next, artificial models and their roles in today's applications. Also, the cloud applications, and also the scientific research by using high performance computing. Also, real-time examples are given by a CMAX. This is also very, very useful. And also, as they are given various deployment coming under ASP that is useful for the community. And also about which is made of on Earth, because the data is playing a very vital role in every day of also other technologies. So overall, it was very good. We thank the man.
Thank you, sir. Thanks a lot for your feedback, sir. You can turn off your video, sir. Any other participants would you like to give feedback? Could you please turn on the video and give the feedback, please? Any other participants, please?
Hi, I am Dr. Rishu from Bennett University. Good evening, everyone. I would also like to express my heartfelt gratitude to the organizers first for really well-planned, well-structured FDP, and the topics covered were relevant and really engaging. Each session had a very valuable perspective and practical takeaways, and I'm very sure it will help me in my teaching and research practice as well. I would especially like to mention the session conducted by Dr. R. Parthasarthi from NIT Trichy on the first 2 days. They were really engaging, insightful sessions, and I think they added an immense value to the program. I can say the program truly reflects the commitment of the organizers towards knowledge sharing, and the panel of speakers that were there, the brilliant speakers from industry and academics both. So I really like to thank you for creating such a conducive learning environment and for giving us an opportunity to get started with high performance computing. And I really look forward to participating in more such sessions and developing programs with you. And really thank you. Thank you a lot.
Thank you, ma'am. Thanks a lot.
Welcome.
Any other participants would you like to give any feedback? You can turn on your video and give your feedback. I would like to give a last call. Is there anyone who would like to give any feedback? Okay. Thank you. Thank you all. Thanks for attending the session. Let's end the session, 6J session. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.